In school, and in first year, you'll have gained experience in making up solutions using pipettes and standard flasks, and where you were measuring concentrations as functions of volume. In these at-home labs, you'll be making up your solutions, concentrations and dilutions by mass instead of volume. And in this video, I'll demonstrate how to do this. In this first example, let's imagine that we need to make up a solution from a solid material and calculate the resulting concentration. So let's see how we do that. In this file I have some salt, and that's what I'm going to make the solution of. And I need to weigh the sample of salt out quite precisely, so I'll use the 3-figure balance for that. I'm going to weigh the salt out onto this scrap of tin foil, but you could use a falcon tube lid or a piece of scrap paper as an alternative. So to start with, I'll put the weighing boat on the balance and then tare it to set the mass to 0. And now I'll use the spatula that comes with the lab kit to weigh some salt onto the weighing boat, where I'm aiming for around 0.1 of a gram. Well, that was quite lucky, but in practice it wouldn't have mattered if the mass had been 0.099 or 0.103, the calculation would have worked just as easily anyway. And my next task is to transfer that salt into the falcon tube that I'm going to make the solution up in. I'm standing the falcon tube up in the plastic cup that also comes in the lab kit, just so that it stands nicely on the balance. And the mass I need is the total mass of the salt and the solvent, so you need to make sure the balance reads 0 before you start adding the first of those materials into the falcon tube. I prefer to use a small paintbrush to brush powder off weighing boats like this, but other people prefer to use the end of a pen or a spatula or a screwdriver or some other method. You should find the one that works best for you. So the salt is now in the falcon tube, and now all I have to do is add the solvent. But I must be careful not to press the tare button because I need to find the total mass of the salt and the water in order to calculate the concentration. So now I have the mass of the salt and the total mass of the solution I've made from it, and so I can go ahead and calculate the concentration. And we'll do that in Excel. The first task is to put the raw data into Excel. And because it's extremely easy to lose track of exactly what data is where in a spreadsheet like this, and to get the units mixed up, it's really important that you label all your data and keep track of the units. It may seem like a faff, but I promise it will save you time in the long run and help you avoid silly mistakes. Now we've got the data into Excel, we can calculate the concentration. Now I imagine you're used to dealing with concentrations with units like moles per litre or milligrams per litre. And as always with concentration calculations, the units of concentration tell us how to calculate it. So if we write the units for milligrams per litre, we write that as mg over L. And then we can write that into an equation. What we're saying is that concentration equals mg over L, which of course means the number of milligrams divided by the number of litres. And we can generalise this equation more, because what it's really telling us is that concentration as a concept is how much of a certain solute is dissolved in a certain quantity of solution. And the units of the final concentration calculated depend on how we've measured that quantity of the solute and that quantity of the solution. So let's add this equation into the concentration cell. we're saying concentration equals the quantity of solute divided by the quantity of solution. And now we need to think about the units of the concentration we've just calculated. So when we were calculating the concentration of a solution in milligrams per litre, we needed to divide the mass of the solute in milligrams by the volume of the solution in litres. And hopefully you can also see that to produce the units of that concentration, all we have to do is swap the numbers for the mass and volume for the units of those numbers in the equation, and then algebra can be used to calculate the units of the answer. And we can use the same approach here. So here, the mass of the solute had units in grams, and the mass of the solution also had units in grams. And we've divided one by the other, so the units of the resulting concentration are grams divided by grams, which we'd normally say is grams per gram, and write like this. But we don't like dealing with too many zeros after the decimal point, so why don't we convert the mass of salt into milligrams and then recalculate the concentration based on that. And of course we need to work out the units for this concentration as well, and they're calculated exactly the same way as before. This time we've divided the mass in milligrams by a mass in grams, so our concentration units are in milligrams per gram. And finally, we need to consider the number of significant figures we could report this concentration to. So remember, of the masses that we input into this calculation, the mass of the salt came with 3 significant figures, and the mass of the solution with 4. But that means that the answer must be limited to the smallest number of significant figures, so we can only report this concentration to 3. Next, we'll look at how we dilute this solution further. As you can see, I've put a small vial on the 3-figure balance, and it's into this vial that we're going to measure the aliquot of the original solution that we're going to dilute. So the first step is to tare the balance. And now I'll use a dropping pipette to add a small quantity of the original solution into this vial as the aliquot. We're going to be diluting this into a second falcon tube, so I'll just get that ready on the 2-figure balance. Now I need to transfer the aliquot into the new falcon tube, but I want to make sure I wash all of it out of the original vial, so I'll use the diluent to wash out the aliquot vial into the falcon tube. And I'll wash it out again with more clean diluent. And now I can keep on adding diluent directly into the falcon tube to further dilute the sample. So that's the dilution completed, and now we can switch to Excel to calculate what the dilution factor is and what the final concentration must be. So let's add the new data into the spreadsheet. And now we need to calculate the dilution factor. Now I know from previous experience that dilution factors are an area that confuses many students. So perhaps it would be useful if I went through a quick reminder about what dilution factors are, and then we'll go through exactly how they're calculated in this case. In this experiment, we made up an initial solution in one Falcon tube, and then we took an aliquot of that and diluted that in a second Falcon tube. And the other thing to remember is something we went through earlier in this video, that the concentration equals the quantity of solute divided by the quantity of the solution, in whatever units you choose. So we could calculate the concentration in tube 1 because we measured the mass of the salt and the mass of the solution we created. And because the aliquot was taken from that tube, it must have the same concentration as well. And we also measured the quantity by mass of the aliquot that we took. And so we can calculate the amount of salt that must have been in the aliquot by rearranging the concentration equation like this. So here, C1 is the concentration in tube 1, big QA is the quantity of the aliquot, and little QA is the quantity of salt in the aliquot. Now all the salt in tube 2 must have come from the aliquot, so when we're calculating the concentration in tube 2, the little q value is QA, the quantity in the aliquot, and Q2, big Q2, is the mass of the final solution in tube 2, and with those two variables we can calculate the concentration. Now because both of these equations have QA in them, that means we can bring them together like this. Now this little QA in the middle becomes redundant, so we can get rid of it. And that leaves us with effectively the C1V1 equals C2V2 equation that many of you are used to. Now the dilution factor is in this equation, but currently it's hidden so you can't see it. So let me do one further rearrangement on this formula so we can see where the dilution factor is. So the dilution factor is equal to the ratio between the two concentrations, or the ratio between the two quantities. That's the quantity of the aliquot versus the quantity of the final solution. Now, I could have rearranged this equation the other way round, and that would give me this answer. Now, the dilution factors calculated by these two equations are not the same. In fact, one is the reciprocal of the other. But they're both valid dilution factors, because providing you know them and the initial concentration, you can calculate the final concentration. It's just that with one of them you have to divide the initial concentration by that dilution factor to get the final concentration, and with the other one you multiply the initial concentration by that dilution factor to get the final answer. So let me show you what I mean. So back in the Excel sheet, remember, I can calculate the dilution factor either by dividing the mass of the aliquot by the mass of solution, or by the mass of solution divided by the mass of the aliquot. So let's put those equations in. Now the next thing people worry about is whether they should be multiplying or dividing by the dilution factor. But if you think about what you're actually trying to achieve, it becomes obvious. Here's the original concentration, and we know that we're diluting it, so we expect the final concentration to be lower. So it's obvious that we have to multiply with the first dilution factor to get a smaller number, and divide by the second one to get a smaller number. So let's put those two equations in as well. So you see, whichever route I take, it produces the same final answer. And so, however you've calculated your dilution factor, You simply have to think whether you're expecting your concentration to go up or down as a result of the dilution, and then work out whether you should be multiplying or dividing by the dilution factor you've calculated. And then the last thing we have to consider is what the units of the final concentration should be. And that brings us back to the idea that you can calculate the units of the product of an equation by following the same algebra that you did to calculate the value of the output of the equation. So whichever way up we've calculated the dilution factor, in this case we've divided a quantity with a particular unit by another quantity with the same unit. So the two units cancel, and in this case the dilution factor ends up being unitless. This wouldn't of course be the case in the event that the two quantities didn't have the same unit, but that's something for you to think about yourselves. But in this case, because our dilution factor is unitless, that means the final concentration must have the same units as the initial concentration. And that's the complete process. So in this video, I've shown you how to calculate the concentration of a solution by mass, and then also how to calculate the dilution of that solution by mass again. And so I hope this explanation helps you in calculating the answers you need for the SOPs.